So I started the recording here again for Ben. I'm assuming you are watching this. So what is happening on the final is like, in next class, I'll be make the question available to you, and it will be due on final week, which is next week, right? And then I'll be talking about a little bit with the exam. It won't be like a regular review class for exam because this is a take home anyway. So we'll be talking a little bit with the exam because the exam will be available during the class. You can ask me a question, obviously not a direct question from the question itself, rather something implied maybe. And let's see what will happen. So our goal would be like, finish most of the symbolic math today. And if we feel like we're overwhelming today, then we'll be continuing with the symbolic math again in next class, okay? So that's the plan. So the recording is on obviously, and not this one, sorry. I'm trying to open the GNU of this Octave or Octave platform here, and would like to open a new editor, and let's start with the code. Now the problem is with this editor here and symbolic math in Octave, in MATLAB you won't be having this issue. In Octave you have to type something in the command window, so this program will gonna run. If you don't type that thing, that specific command, it will not gonna run, okay? Just to give you a heads up, okay? We'll see what to type, but for now let's start with this code itself. So first of all, the title for today's class is the symbolic math, right? Then the title description is the intro, because we won't be doing that deep inside. So intro to using, you won't be exploring that deep inside for this symbolic math. So intro to exploring the symbolic variables, okay? And the usual things like your email, your school name, date, and what to do, what is left, all those things in the heading that you'd like to put, but I'm gonna skip all of this. What to do. Let me know if you have questions. So CLC clear, close all, what those things means as well, right? You'll be started typing those things first, and let's start with our first symbolic variable. So we are creating the symbolic variable. Anytime you are typing something, it will gonna give you some directions. That is that the thing that you are not tried. So you can simply press enter and then choose it. So the condition of symbolic math, anytime you'd like to define a variable, you should be using this command. I'd like to say command because it's like hold on, CLC, clear, close all, right? So it's called sims. Always remember, like from Simpson, sims, right? Sims. So sims t, say like this is the variable that you are trying to define, and you'd like to put a command. So this is the sims command followed by variable or variables. That's why I'm putting this that you want to make symbolic, okay? Like this t, say like you have equation with this t. All right, so that's what you want to do. Say like you have this y variable that is equal to this equation that goes with this t symbol, right? So you have this equation like a quadratic equation where you have t square plus t plus 10. Now here's the catch. You see, if you don't define this t as sims, that this will gonna not work at all. So you gotta define or introduce the Octave or MATLAB that this t is a symbol that you'd be using in equation, okay? That's why you have to use these sims, okay? And then obviously I'd like to put some comment here. So this is the some equation, some quadratic equation. You can use different equation, whatever you like, doesn't really matter, as long as it's a quadratic equation. Then you'll be getting something similar. So some equation which is y equal t square plus t plus 10 that you define, and you define this value of the t is 19. Now if you're going to define this value of the t is 19, you'd be getting the solution for y with some numerical value, okay? Because remember, quadratic equation solution is what? If you have a quadratic equation ax square plus bx plus c, then the solution would be what? Minus b plus minus square root of b square minus 4ac divided by 2a. We have seen that, right? So this A, B, and C, you had the value, right? Like 1, 1, and 10, right? A, B, and C. And then your T is 19. I have this thing, I'm sorry, should be equal to that, right? And then in this case, if you are in a situation like where the T value is defined already, instead of solving it like quadratic equation, just one value that you have, then you can get the value of y, okay, by plugging the value of T by using this function called eval. Okay, eval means it's a short form of evaluation. Okay, eval. So you're evaluating that function y, where the value of the t is 19, and then you'd like to put the unit as second. Usually t is for second, but you can literally use any unit. In this particular case is 7. Okay, so then this time, I'm sorry, this one I'd like to put it here, and then here I'd like to put use this eval function to determine the value of y, right? So what does it mean? If you're going to run it, try to see what happens. It will not going to run. So if you're going to go command window, see what happened here. It says error because this seems it doesn't understand. So what it says you got to type this thing called package load symbolic. Everybody see that? PKJ, package load symbolic. When you're going to try to run it, this message is going to show up. You're going to copy it or you're going to type it, whatever, but you're going to paste it in the command window and press enter. Make sense? Now try to run it. So see, it's still working, right? So it's loading the package. So for the first time, it will going to take some time, you see, and then you won't be seeing anything still. Okay, the reason you are not seeing anything, you didn't define it for any variable. Let's define it for A. Okay, and then try to run it again. Then you should be seeing the value of A by typing A. Okay, do you see A equal to 390? Now what I did previously, I didn't have A here. If you don't have A or anything, you take out the semicolon. The result will going to display directly, right? If you didn't define A or any variable, so do it like this, without any semicolon, and then run it. You should be getting a value 390 again. You see answer equal to 390. Got it? Huh? You should be typing this package load symbolic PKG. You did that? The package loaded. You need some help? You want me to come? Ethan, you got it or should I come?
Mine's working.
No, you got the JSON's issue?
I'm helping Jason.
Should I come? Okay, I'm coming. You usually like to type, Ethan. Jason. Okay, now save it. Copy this package load symbol. Type it. No. because when you copied and pasted, something happened, means like this space or whatever, I don't know. It's loading. For first time it will take a little time. You don't have a semicolon right after this develop like. Yeah, see answer 390. All right. So using the solve function, now we're going to learn the solve function, okay? So the next idea would be what? We're trying to deal with multiple variable. We had t only before, right? Y equal. What if we have two variables like t and c, and it could be x and y. It doesn't really matter. Like multiple variables, okay? So how are we going to deal with that? So let me start typing the notes here first. So we can create multiple variables at once, okay? And in that case, obviously you got to use the sims every time you'd like to define variables for symbols, like sims t, x, c, three variables that you are defining, okay? Let me put a note here, just put spaces between the variables, okay? So that's the clue how to define. So then say like you have this y square, right? You have a variable y2. You already had y1 before, right? Y equal to t square plus t. And again, all things that I'm defining here is kind of arbitrary. You can do literally any variable that you want. So it's like you have x plus t. You have this t, x, and c, right? These three things plus 2c. This is multiplied, right? And then you don't like to put any semicolon or anything. This is the equation, brand new equation that you would like to define. Remember, in last one I did says like, what if you are not defining the t variable? Like you did define the t equal to 19, and then you got the use the evaluation function and you got the final result, right? So what if you have this system of equation, one of the equation you would like to define this way, right? Which is obviously x plus t plus 2c. So just keep it as it is. But later you will gonna use it, but just trying to show you what if you'd like to deal with the multiple variables. Okay, if you're gonna run it, then in the command window you should be seeing, did you see your y2? Your y2 is defined this way. Everybody see that? 2c plus t plus x, right? So that's the equation that you just defined. All right, moving on. So you'd like to use the solve function. That's the next thing. So using the solve function, remember I did show to you the code for the solve function. This is solve itself, right? And for that, let me give you a little bit more intro. Say we want to solve x square minus 9 equal 0. What is the value of that? It's a quadratic equation. Anyone remember? Isn't it x equal to 3 plus minus 3 means 3 and minus 3, right? You remember that? Okay, so I'd like to get the solutions, right? So how are we going to get it though? So first of all, you rewrite. I mean, if the equation is like that, then you'd like to rewrite it to the way that I was showing before. But first of all, you want to rewrite the equation in the form stuff equal 0. That means like, in other words, as meaning like x square minus 9 equal to 0. The thing that I was showing it to you. Okay. Then you'll just use simply the solve function, okay? So let's start with that. So say like would like to clear all the variables and see means clear the screen as well, right? All right, then let's use this sims function again. Sims x, only this x is a variable for your case. So you are defining the symbolic variable x, okay, and then say like you are defining a variable called equation, eqn equal x square minus 9. Now remember, your equation was what? X square equal to 9. You got to write it such a way so it should be equal to 0, which is x square minus 9. That's why all those intro, you see, all those things that I was talking, just because of this, the way you can write this. So equation is x square minus 9. What does it mean again? It means x square minus 9 equal to 0, okay? All right, so let me put a semicolon here, obviously, and then write a note here. We are defining the equation here, right? And then you have two solutions, obviously, in this case, right? Say you'd like to write the first solution as like x underscore solution 1, because you know the result is what, like plus minus 3. So you have this solve function that you are using for first time, and you'd be writing eqn, that's the equation defined, okay? And then you don't want to put a semicolon, so let me put some note here. So use this solve function here to find the roots. You know, roots of equation, what does it mean? X1 and x2, that's what I'm referring by here, roots. And I will have a second solution, which is solution 2 in this case, and then solve x square. The second solution means, like, instead of writing this equation, you could have write simply x square minus 9, and then it would be giving you the same value, right? So let me do it here. So, or perform all in one step instead of writing these variables, you know. So if you're going to run it, you should be seeing it shortly after running it. You should be getting the returns of this solution, right? 2 times minus 3 and 3, because both satisfy the equation, right? Because it's a quadratic equation. Okay, you would like to see the results, so you just run it. Should be seeing it's loading, right? And you should be seeing the results twice once the loading is done. Do you see? You have this result came twice, okay? Now if you're going to put some semicolon here, it's fine as well. That way you won't be seeing the results, but you know already what I'm saying, right? You have the same result came twice. So one time you're just writing this y equal that equation x square minus 9. Another time you're just simply putting the equation directly on the solve function. Got it, Jason? Moving on. So say like the next thing would be, say like we would like to solve a system of equation. Means like you have 2 equations, 2 unknowns, right? How are you going to do that? The example I was showing before, right? So let me put it this way. Say we want to a system of equation. Okay, so the first thing would be you are defining the symbolic variables. What I meant by that, say like sims x and y. Remember, you got to put a space in between those variables when you are defining the sims. Okay, always do that. So if these 2 variable, right, and then you would like to define the constant or define the equation. So define the equation. You have these 2 equations. The first equation, you can say, okay, equation eqn1 or equation 1 is equal to 5 multiplied by x, okay, plus 6 multiplied y minus 7. So that's your equation 1. You can write this thing as like the whole equation, equation number 1. And again, you can define the second equation, kind of doing the similar things by assigning a variable, say like equation 2 in this case, and then say like you have this second equation is become x plus y minus 2. Now you guys remember, right? I was talking about this before. The you have an equation. Anytime you have equation, you should be writing only whatever is in the right and left side. Everything needs to move to the left side, and it should be equal to 0, right? So that's what you should be writing. So remember that for sure. If you don't do that, then you won't be getting the correct answer. And then this time you'd be using eval function. Remember, so we had this eval function used before, right? Eval y. So the same thing we'll be using for these two different unknowns. What are those unknowns? X and y, right? Again, two equations, two unknowns. So how going to solve it? So you have this. So use the eval function, right, to retrieve from the structure arrays. Okay, what does it mean? It means, say like you're defining x equal something and y equal something. Now these two unknowns, right, x and y. So you're evaluating what? You're evaluating, first thing first, you'd like to use the solve function to get the answer. Okay, so I'm sorry, I skipped this part. The solve function will gonna give you this result for these two equation. Okay, so say like you are gonna define this answer a variable. Okay, so you say like you would like to define an answer a variable. So answer equal to solve equation 1 comma equation 2. Sorry, I skipped that part. So then this will gonna solve system of equations. Now this evals function that I was talking will gonna be used to display the results like x and y, right? So like, you know, if you're gonna use the eval function, you should be using this answer dot x. Remember, what is this answer? Answer is the variable that you define where you have both x and y value. And like, let me put some notes here next to it. So it will gonna evaluate the value of x. Okay, and I'm gonna kind of copy that and just use this thing as I'm gonna do the same for the y value. Okay, and then I'm gonna save it and I'm gonna run it, and it should be giving me the value of x and y. In case if you are still typing, I'm leaving it here, but it should be giving me the value of x and y, and obviously I got the value of the x and y. As you can see, x is 5, y equal to minus 3. That's how we're going to solve the system of symbolic equations, right? And you obviously got to understand, right, it's just not two equations only. If you have like 10 equations, 10 unknowns, you can do the same, right? Everybody got it? In the exam, if you're going to see like 3 sets of equation, you're going to get confused, or 4 sets of equation, you're going to get confused, or you can solve it. System of equation, like 4 equations, 4 unknowns. All you got to do, like, you know, similar things, right? It's just 2 equations. You define equation 1, equation 2. If you have like, say, like x, y, z, and n, like, you know, 4 unknowns, right? 4 equations I'm giving you. Can you solve it? Should be the same thing. It's not like you're solving it by pen and paper. The computer will going to solve it for you, like Doctave or MATLAB. Ethan, you can solve it, right? 4 equation, 5 equation, 10 equation, doesn't really matter. All right, so then, obviously, we'll be moving on the differentiation and integration, the thing that we learned, right, after the symbolic equation. So let's start with the differentiation. So for that, symbolic differentiation. Symbolic differentiation. So symbolic differentiation means what? You see, we're trying to find dy by dx, right? And then to find it, first of all, let's clear all the variables, right? Clear NCLC, clear all NCLC. Okay, and then let's start with defining a variable by using this sims x, and then let's start with the equation, say like y equal x square plus x. Okay, we did solve it just on pen and paper, remember? So if you're gonna do, remember, if you're gonna do the symbolic differentiation twice, what would be getting? I probably had a little bit different, right? You should be getting 2 only, okay? Because the first time differentiation is gonna give you what? 2x plus 1. Second time differentiation is gonna give you 2, right? So just to give you an idea. So obviously this is gonna the equation for you to solve by doing the differentiation. So this is the equation to take the derivative, of, right? And then what you want to do, like you want to find this dy by dx, right? And you want to, we have done it by hand, right? By hand, and expect dy by dx. What would be the result you are expecting, Ethan? 2x plus 1, right? Jason, you got it? So then to solve it, like, you know, actually get the result by doing the by using this octave. You guys remember the function? Which function to use? I was talking about it. Is it diff diff? That's the function, right? So that's the function we'll be using. Okay, let's do that then. So we have this solution. I mean, you can literally define any variable. I'm using solution 1 as a variable, and then I'll be using this diff, right? So diff y, because I already defined y, and this would be giving me what? This diff is the function for differentiation in octave. So in octave or MATLAB. All right, and then you can save it and run it and see what happened really. I mean, it will gonna take some time to load the symbolic math. You guys run it. What value are you getting? I did semicolon there, so I'm not seeing the result. Okay, let me run it again. Should be seeing the result. Or I can type it in command window and see the solution 1 as well. The symbolic math is really slow. So you see, you have this 2x plus 1. Everybody see that? Solution 1. All right. But here's the thing. You're going to pay some money. MATLAB is not that slow, okay? But this one is slow in Octave a little bit. Because every time you have to upload this package load symbolic, okay? And that's why it's slow. In MATLAB, it is not at all. All right. But there's a trade-off. Spending money, no spending money. So the indefinite integral that we just computed. That's the indefinite. Remember, Jason, I was talking indefinite and definite. What is definite? If you have a limit, right? So like you have a limit of some value, okay, lower and upper. So then what would be the result? We didn't quite see it in pen and paper. Kind of skip that part, but let's see how it be looking here in code. So say like you'd like to find the definite integral, right, of x squared. from the integral limits are -1 to 1, right? So that's what you would like to solve. And obviously you have some idea already what you're going to do. Just define a variable. This time it will be solution 2, right? As well and 2. And then using this, I'm doing the integral, right? There's the, I'm skipping something, I'm sorry. The int, let me write this first, okay? And then I skipped something. I'm going to come back to that shortly, but let me write this. What would be the result for indefinite integral if you have a limit of -1 to 1? What is the code, right? So this is the code, and this should be giving you indicate the limits for the integration. Now I obviously missed some code, but let's run it, and you should be getting the indefinite integral result. Okay, now here is the thing. I skip this part. Say like I would like to do the definite integral. So this one, solution 3, and then int x square. So that's my definite integral, right? So let me put the note here. This int is the function for integrating. Note this was the indefinite integral. Okay, that was missing. So this line was missing. I just add the integration for definite integral and indefinite integral. So now you have these three solutions. Actually, you can write this thing by changing this solution 2 and 3, right? So run it. Should have like these three solutions. The first one is the differentiation. The second one is the indefinite integral. The third one is the definite integral, right? Now we're gonna proceed further with what if we'd like to do the differentiation twice. Okay, a little bit advanced. What if we'd like to do integration twice? What are the codes for that? But these are the basic things that I'd like to start with. And then obviously once you're done with that, it should have like this solution 1, 2, and 3. Did you see that? The 3 result. So this is the, this is what? This is the definite integral. That's why you have a definite result, right? 2 by 3. Once you put the limit, -1 and +1. This is the indefinite integral, right? X cube plus 3. So you have like the x cube, x square, right? If I'm not mistaken, x square. So if you do the integration x square, it would be x cube by 3. And then finally, the first one we have seen before, that's the differentiation, that's 2x plus 1. Any question up to this? All right, moving on. You guys want to take a break, or you want me to finish the whole thing? Done, done, done. You good, Jason? All right. So not that much left, probably 5 minutes worth of lecture. We are done almost. Okay, so two things that I would like to cover. First of all, what if we'd like to do differentiation? Okay, like a little bit complex. Say like you have a differentiation with, remember the complex equation that I was showing it to you, which requires the product rule, how to deal with that. What if you'd like to do the differentiation twice? Those sort of thing, right? A little bit advanced. So let me put some note here. Say like you would like to find the second order differentiation, right? So say like I'd like to define as seems again, seems I don't know, maybe z this time, okay? And then let's say I'm defining a function again, this time y again I'm defining, right? Doesn't really matter, but you have this seems z there. So let me start typing some values as z square plus 2z, 2 multiplied z, that's what you'd like to put, plus say like some constant value 10, right? So if you're going to do the derivative, it would be dy by dz. not dx. You understand that? And the result would be what? First derivative result would be again 2z plus 2. You understand that? All right, so let's see if we are getting it right. So we'll be doing the derivative one time. I'll just do a little bit cheating here, right? Copy that. Don't forget to put a semicolon here for sure, right? Don't put a semicolon after the sims though. And then I'm copying this. I have this dy by dz, right? And then I have this equation, so I'll just do a little bit copying, pasting. Okay, I have this dy by dz here. Okay, and then this one would be 4. You see that? What did I do? So what I'm doing now, if I'm going to run it, right, I should be getting a value of solution 4 now this time. And I should be getting like 2z plus 2, right, for solution 4. I'm waiting for the result to come up. Once the result will come up, because it does load that, and it will take time. Did you see that? The solution 4 is 2z plus 2. Everybody see that? Okay, so it does make sense. Now, this is not our goal. We have seen it before already, kind of in a situation where we have x instead of z, right? Now we're just seeing what happened. We have a different variable, but that's not our goal. Our goal is to find the second derivative, right? So the second derivative or second order of differentiation, if you're going to find it, second order of differentiation, then what you got to do, you just have to use diff comma 2. That's it. Okay, or you can do the differentiation diff y comma 2, or you can do the result like the solution 4 differentiation one more time. Does it make sense? Two way you can do it. Okay, let's see how I'm going to do it. So find the d square y divided by dz square, and it's a little tricky to understand, right? What I'm doing here, d square y. It's a little tricky to understand. You see, instead of x, I have z in the numerator, right? But we're doing the derivative with respect to z in this case. All right. So I have that, and then I'm gonna write the equation, obviously. So my equation, let me do it this way. So select solution, and this time I'm defining the variable. Again, you can literally define anything that you want. This is a second order derivative, right? We're doing so diff2 means differentiation. We're doing it twice, right? And the code, like in this case, the function is so important. You can change it. That is diff, right? And then in the parenthesis, as I said, like you have two solutions, right? You can either do like this solution, like solution 4, okay, and then it will be giving you the result second time, or you can still deal with the original one, y comma 2. That would be doing the same thing. Does it make sense? So you're doing the derivative twice, and the result, what would be expecting? 2, right? The final result would be 2, right? Is that what you are expecting? Ethan, are you seeing the? I'm not seeing. Okay, solve diff y. Okay, excuse me, it's not giving me the value. Why? Did I run it properly? Let me run the code here. Yep, I'm getting it. I don't know, for whatever reason it was not running before. Do you guys have the solution? For me it was not, but most likely I didn't run it, that's why. But anyway, if you don't like to display the results, you can put a semicolon, obviously, all the time. And then I'm gonna put a note here. So the 2, you see in the code, the 2 inside the diff. So this 2 refers to, it will gonna tells the diff function that we want. Oh, I'm sorry. We want the, what do you want? What do you want, Ethan? We want the second, right? Second derivative. You got it? Okay, I'd say like the final things that we'll be covering here today, which would be integration. If you'd like to do, we have done the what, like the definite and indefinite integral, right? So in advanced topic, like if you'd like to do integration twice, can you do that or follow the same approach like y equal to 2? No. That's what I was saying before, right? You're not gonna get confused because you see it has int is the integration function, right? Int has this upper and lower limit. So if you're going to start to put stuff after the comma, you're going to get confused with the upper and lower limit. So that's why the only way around for integration would be you have a variable defined and get the first integration result, and once you have the result on that variable, use that variable to do the integration again. Does it make sense? Okay, so in other words, what I'm trying to say here, let me put the note here. So notes on integration, and that's the last thing that we are doing, and then after that we don't have anything. So in order to take the second integral, must compute the integral of the first one. What does it mean? For example, so say like this time I'm doing solution, right? Solution 5 equal int of, what was my before solution, int of solution 2, right? You see that what I'm referring by that? So now you'd like to click solution 2, so it should match, right? Solution 5 is a new variable. So what will happen once you're going to do that? Let me put some note and then you can run it and see if it matches. So in order to take a double integral, must integrate independently, right? That's what I was trying to refer, over each variable. Okay, so obviously you'd like to run, your goal is to see the solution 5 result, right, this time. So you'd be expecting for solution 5, what would be expecting? So you had like what, solution 2 has x cubed by 3, solution 4 has like x to the power 4 divided by 12, right? You should be seeing solution 5x x to the power 4 divided by 12. Do you see that? X to the power 4 divided by 12. If you see that, understand the whole class, you are done for today. Okay, again we have done officially with the symbolic math. I would still expect you to come on Wednesday, and I would be talking with the final exam. Obviously on that day the exam will be available to you. It's due on next week Monday, right, the final exam. So we can talk about the exam, not the solution. Maybe if you have question with the exam, right, say that you are not understanding this or that, you understand? So these are the thing I can talk about with the question. I mean very limited obviously, and the purpose of that is like, you know, during exam you always have the access of the instructor, right? Since this is a take home, so you can talk with me. Okay, you don't have to wondering here and there what is going on. And same time we'll be doing a review as well, like the usual review that we usually do. Okay, any question? If not, then you know what I'll be doing next. I'm gonna save this, upload this, the code, that .m file that you're seeing here for this week 14 lecture 1 symbolic math, and as well as there will be 2 video lecture uploaded. Okay, the first one is for the theory, the second one is for this code. Okay, and I'll all see you around. Okay. I thought I saved it. Let me confirm. I didn't save it. I have the original code. Go to that. See you, man.